Just past the hours, 9:30, so we ought to start. Today is quite a different set of issues from yesterday's. We are going to be studying human nature engagements, interactions, and why we may have cause to be worried. Now, if you, on the other hand, if you were woken up in the middle of the night and told that you had the choice of being dropped at random on Earth, which period would you choose? My guess is you would choose now. And pretty much every month or two, I receive a book telling me how wonderful life is, how much progress there has been, and we've never had it so good, which is all true by the fact that you would choose to be born now than any time in the past. So what is the angst? And the angst is not left-bang existential angst. It's a worry that maybe we are borrowing from the future, and that the good life that we have may be jeopardizing our children, grandchildren. Paul Ehrlich, my old friend in ecology, thinks in terms of his children. I'm more optimistic, so I think of great-grandchildren, that we are shortchanging them. That's the class of issues that we'll be discussing today. Question, why? Why are we making such a mess? If we are making a mess, I'll come to that in a minute. It's very much the realm of economics, and a great deal of work by environmental and resource economists in general has illuminated the reasons why we might be smart, very smart, and we pride ourselves in being smart, but collectively we are a disaster. That can happen. And one of the things that game theory teaches us is the mechanisms by which that can happen. We do not have to postulate either myopia or stupidity. We'd be very smart and get into a mess. If you ask historians about the good life, they will trace it back, the origins of it, they'll trace it back probably to the Stone Age, saying that the momentum started there, or the Romans certainly. Conventionally now it is the Industrial Revolution as the start of the big breakthrough in the quality of life, momentary life, current life. But more recent work suggests that it's much more recent. In 1950, world population was 2.5 billion. Aggregate income, world income, was, in current prices, about 5 trillion international dollars. So the average world, I'm averaging everything now. Average world income was about 2,000 international dollars. People were poor on average in 1950, but the impact we had was, let's say, if not proportional, certainly a monotonically increasing function of, let's say, GDP, in which case we'll be looking at $5 trillion world economy. 2015, the last year, latest United Nations work, statistics, world population is 7.4 billion, and the world output income is now a $110 trillion economy. Per capita income average world is obviously 15,000 international dollars. So we've had in a 65-year period a 22-fold increase in the most immediately measurable economic activity, namely income or GDP. We know all the errors in GDP, but that's not the point here. It's that if it is translatable to the impact we have on Earth or the biosphere, then we are talking big numbers that have taken place very rapidly. There's some corresponding data on it recently from the physical sciences. Recently, Science published a multi-authored paper, which is to be taken seriously, who reviewed an 11,000-year period tracking of the major biogeochemical signatures, including, of course, carbon, biodiversity, species, and phosphorus and nitrogen. Those are the four included, but there are others as well. And what they found was that the hockey stick that we are now familiar with from the carbon story is approximately corresponds to the other signatures as well, and that, roughly speaking, the big rise was about 1950. So that's a second, if you take that seriously, and the only reason I take it seriously is because I'm an economist, so everything has to conform to my kind of statistics, it corresponds to the 22-fold rise that I mentioned a minute ago. Then, of course, there is the, I think, really remarkable work that only one research unit is conducting, which is the Ecological Footprint Group. That kind of work should be done by the World Bank, IMF, OECD, but it isn't done. So there is a sole group who think of the biosphere as in the aggregate, as something like a renewable natural resource, churning out stuff that we need, food, water, fibers, timber, and dumping ground for our waste, and so forth. And they find very correspondingly that over the past 30, 40 years, there has been a sharp rise in the demand relative to the supply. And so that if you take the metaphor of the renewable natural resource, then we are eating beyond its productive capacity. So today, we'll be discussing these issues in various forms. Our first speaker, the arrangement is going to be pretty much the same as before last. Approximately half an hour for each talk of the plenaries, followed by 15 minutes of discussion. And we'll have two in this morning session, first part of the morning session. And the second part, we'll do the same thing, but we'll follow it up with the remaining half an hour or so by a general set of questions addressed to all three. Okay? Is that all right? Our first speaker is Peter Kareiva. He's director of the Institute of Environment and Sustainability at UCLA, and he's just flown in yesterday, so I'm quite intrigued. I'll be jealous by the time he finishes, because I would have been dead by now. This is an 8-hour flight. Prior to that, he was chief scientist at the Nature Conservancy. I've never had the pleasure of meeting him, but I've heard of him from, of course, Paul Ehrlich and others. He's a member of the National Academy and the American Academy of Arts and Sciences. It's a great pleasure to have you here.
Okay. I started off as a conservation biologist, and we are here to talk about existential threats. As a conservation biologist, you're worried about the absolute extinction of a species. And that might seem like that's a leap to thinking about the types of disasters and catastrophes that might befall us as a species. I don't think it is. I don't think it is, so I want you to have a little bit of fun this morning and think of us as, if you were a conservation biologist looking down upon this planet, and you would ask, well, is the human species at risk? What are its threats? And what can we do to avert the risk? But just to introduce it, because I'm going to come back to these at the end for some lessons we learned that are pertinent to how we ask these questions about humans. Some of the species I worked on was spotted owls, an iconic species in the Northwest, commanded a lot of attention, and the salmon in the Pacific Northwest, and other very symbolic, important, commercially important, and culturally important species. And when you work as a conservation biologist, you immediately notice some difference between talking about humans. Conservation biologists get pretty vivid about extinction. I don't think you see many pictures with the humans on a plaque and sort of bemoaning the disappearance, but you do for salmon. And another thing that happens when you think about the extinction of species is there is a tendency in the environmental narrative to diminish uncertainty and be very assertive about what's happened. I was working for the federal government at this time in charge of fisheries conservation. This is a graph and a full-page ad taken out in the New York Times by almost every environmental group. You can't read the print, but what it says is if you don't do something, with certainty, this species will be gone. In this case, it was remove the dams. And it gave a date, 2017. So we're about there. We didn't remove the dams, and there's absolutely no chance of this species going extinct in that time. Zero chance whatsoever. And the data actually showed that at the time. I think perhaps in some sense, for thinking about our existential risk, humanity's civilizations, maybe Hollywood's a better place to turn. I live maybe 2 kilometers from Beverly Hills, and we all have some sort of guilty pleasure with post-apocalyptic movies, end-of-the-world movies. I don't think you could deny it. Certainly the box office supports it. If I just went to the 10 most popular end-of-the-world movies, they gross $2 billion, and that's without inflation. $2 billion. The lowest of those 10 was $200 million. So it's extremely resonating from Hollywood, sort of this notion of worrying about the extinction and the end of the world. There's an environmental twist on it, and that's captured here. It's, well, we're the ones to blame. You want to save the world? Kill yourself. This is not a policy recommendation. But it is interesting to ask, just as an exercise, I went and looked at the last 40 years of these types of movies. And I asked, what was the cause? What was the cause? And in over 55% of the movies, the cause was us. And it's kind of interesting. I don't think they might not have gotten to this Hollywood if we were to rank them. So over at the furthest left, that bar is aliens or collision with comets or planets. We're not to blame there. But the highest ranked cause for us is technology run amok. So technology just getting out of control and exterminating us in a civilization. The next one is an environmental disaster. And those two stand out, really, in Hollywood as what we might do to cause our own demise. After that is war. I'm surprised war comes so far down. And then punished by God, and I take that to be for our sins. So this is my gratuitous Donald Trump photo, but I actually think it fits here, and I'm going to make a case from that from 2 points of view. If you studied spotted owls or salmon, there's no way the addition of any single spotted owl or salmon would affect any of your consideration of risk. In the U.S. environmental community, his election has terrified the environmental community. There's no question about it. And he wants to get rid of NASA's Earth Science. The head of EPA is a climate denier. Dismantle EPA. The Secretary of Interior, recommended Secretary of Interior, all the public lands open to oil and gas exploration. Secretary of State, you can just go on. You know, this is something unique about humans compared to other species, is that you can imagine single individuals, maybe not a huge, but certainly a measurable little tick in the risk meter. And I don't think, it would just be Trump. It could be something else. The other interesting thing about Trump, I think, is we have something in common with him. Those of us who worry about the future and this existential risk, and Donald Trump has something in common. I don't know if you've had a chance to read it, but it's the holiday season. Todd Friedman tends to come out with books in the holiday season, and he's come out with a book, and let me see if I remember I get the title right. I think it's Thank You for Being Late. And the thesis of that book is we're in this great acceleration. It's the hockey stick model. It's just everything's taking off. In Friedman's language, it's the destruction of biodiversity, it's climate change, it's globalization. And it's so fast he uses the image that your head's thrown back like you're at 60 miles an hour in a car and you're just accelerating. And he attributes it to the greatest inflection point in the change since the invention of the printing press. And in this book, he gets very nostalgic from the community he grew up in. Well, that's not that much different from what the Trump supporters and Trump worries about. It's just things are going too fast. They just feel out of place, disoriented with all the change. It's not as good as it used to be. There's a nostalgia. And it's certainly true, things are going fast. Not just nitrogen, phosphorus, population growth, stock market. From 1975 to 2006, the change was from average length of time stock was held of being 6 years to 6 months. That famous sort of little hacking incident where they hacked into Associated Press and sent out a tweet that there was a bomb in the White House, a phony tweet, the bomb in the White House, and Obama was injured. In 5 seconds, Standard & Poor's dropped by 1%, lost $130 billion, just like that. In a more ecological sense, there's been a study of 100 time series where you go back to the same place. Very rigorous scientific study. These are not places that are destroyed or developed or under change. These are natural places. And even going back and looking at those, the change you see in the natural world is if you go back in 20 years, 1 out of 2 of the species would be different. And the business lifespans, I've been tracking the business lifespan, this is the US, in the last 20 years has fallen from 55 to 31 years. So instead of living on average 55 years, the business now lives, it's kind of scary. So let's start by talking about sort of theory and conceptual models. Again, as a biologist, I bring to this a sort of a mix, and it's a little bit, I'm going to be a little bit sloppy here. You could make it quite formal. There's a lot of overlap between evolution and complex systems theory. Both of those theories, the theory of evolution and responding to change, and complex systems theory and what gives you resilience, share a lot of features in common. What they share in common is the notion of certainly to respond to this change, to avoid extinction, you need to experiment or have mutation in evolution. Modularity, that's the sense that you're divided up into different populations, or if you're banks or financial systems, you're divided up. Variety and diversity being essential to the notion of resisting extinction. So when you're a conservation biologist, many cases of species very, very close to the brink of extinction, you can import animals from far away, bring in new genes, and the populations will start to recover. Been done in the Florida panther and other cases, and redundancy in the system. So how do we do? So how does the world do in terms of as a civilization, the human species do, in terms of having these features? This is a study that was done for more political reasons about the role of government versus the private sector. And even though it's framed that way, I think it's an interesting lesson for a different reason. So they went and they looked at expeditions to find the Northwest Passage. So there were 92 of those expeditions. And they categorized them as government versus private sector and looked at the fate of them. The basic message was that if you're a government expedition, your risk of mortality was 6 times, and the risk of the ship, just losing the ship altogether, was twice. That's not the point I want to emphasize, private sector versus government, but if you go in and look at the narratives of what went wrong, it is pretty interesting. The government ones tend to fail because they follow protocol. They had procurement procedures, they had to get the fixed uniforms. They had tents they had to use. They had fixed and rigid procedures, and that was not adaptable. The expedition that succeeded, Amundsen's, abandoned all fixed protocols. They learned to use sled dogs. They adopted the natives, the Inuits, fur coats instead of the standard uniforms. They built different housing and so forth, and that was the expedition that succeeded. So the notion of not being locked into an approach, but really borrowing from other cultures, kind of figuring it out. You could ask this at conservation organizations and climate change. So when I was chief scientist at the Nature Conservancy, we had programs in 40 countries. And like any conservation or environmental group, we did a lot of policy work in DC to try to get cap and trade and various climate policy passed. So I was interested in, well, that's all well and good, but we manage land. The Conservancy owns land or manages land. What does this big conservation organization do in the face of climate change? So we did an exercise, and you might even think of it as an experiment. We picked 20 projects from around the world. We spent a lot of money doing this, and then we went to the project managers who lived in the country. It would be Mongolia, China, Indonesia, many throughout the US. And we taught them how to use downscaled spatial climate models, full repertoire of models and looking at what might happen. We taught them how to interpret it. We spent a year kind of asking them to rethink their project. And so they went through this exercise with a lot of help. And Without exception, they viewed climate change as a real threat to what their conservation goals were. They had a very hard time changing what they did. They had a very, very hard time changing their management thing. And in fact, only 2 out of those 20 projects, in spite of all this hand-holding and a lot of help, actually had a transformative change, which would be, the climate's going to change so much, maybe I should rethink the objectives and the fundamental approach of the project. But if you're a land manager or a freshwater system, whatever it is, 2 out of 20 is too little for rethinking it. So even in this conservation group, it was just very hard institutionally to change. I think I'll skip the technology because I think we've heard enough about technology. There's another shortcoming we face, and it's what I would call narrative shortcomings. As an environmentalist, we think about some of the issues facing us. And one narrative shortcoming is this one, the fragile Earth. You've seen this, almost every environmental group uses this word fragile quite a bit. I do not think it applies. I think it's, I don't worry about life on Earth. You might worry about human civilization on Earth, but life on Earth will continue. Evolution is incredibly ingenious. Life on Earth will continue. You just look at the range of environments. Threats to our economy, our way of life, our civilization, much, much more serious. And the problem with the fragile view is it sometimes leads us to underestimate the innovations of natural systems and figuring out how to take advantage of them. So when you're managing endangered species, you do consider bringing in a mountain lion from 1,000 kilometers away to breed with a Florida panther to save the species. You do consider that. But it's not that widely considered. These are some hybrid species that are remarkable innovations. 2 that we've constructed, the grapefruit. I happen to like grapefruits and wheat, and you all enjoy the benefits of wheat. But some interesting ones from the natural world, just to give you, that have arisen within the last decade in the United States that are amazing innovations. This is a tiger salamander up there, and it's a tiger salamander in California that's a hybrid with one from Texas. The Texas salamander was brought into California probably as bait for fishermen. It's much bigger, it's more aggressive, it's got a bigger mouth, it's learned to feed. There's much worry about it taking over California, but in one sense, it's an amazing tiger salamander. It's quite a beast. That there is a coyote. Many of you know this, but the coyotes, the traditional coyotes on the West Coast, as you move to the east, they got wolf genes in them. They're 30% bigger. They can take down a deer. They've even taken down a runner. There's 4,000 of them in Chicago. 4,000 coyotes running around Chicago. It's a different, a wolf gene, and it's a different species. Incredibly innovative. And then sort of normally as environmentalists, we worry about non-native species, invasive species. I worry about them too, but there's a flip side. They can also represent sources of creativity. There are more red-crowned parrots in Los Angeles now than there are in Mexico. In Mexico, it's threatened and endangered, but now you can hear them and see them in Los Angeles. An analysis of mammals is that 1 out of 4 mammal species that are non-native, that means they're outside where they normally came, so they're invasive, you worry about them. Back in their home, they're threatened and endangered. Now, is it bad that they're non-native? That might be the only hope for those species. Depending on your view of nature, you can either take advantage of that or reject it. This is one of my favorites. This is an ecological disaster, but it's just stranger than any of those Hollywood movies. Little house mouse. Little house mouse got probably off a British seal or whaling ship in Gulf Island in the South Atlantic. And within less than 100 years, that little house mouse is now that big, carnivorous, and it's an ecological killing machine, eating albatrosses and stuff like that. So that's just to emphasize, evolution's ingenious. It does pretty amazing things. Recent paper published in the Royal Society makes this point. This is by James Bull and Martine Marin. And yes, we cause extinctions, but and we shouldn't stop worrying about that. But on the other hand, there's 1,359 documented extinctions since the end of the Ice Age. We've domesticated 743 species. We've moved to new habitats, 891 species, which is really creating a new species. And you compare those numbers, 1,400, 1,600, sort of the same order of magnitude. Now, there's certainly many extinctions that we don't know, but it's just the point that it works both ways. There's opportunities for creativity from nature that maybe we should be taking advantage of. This is my off-kilter narrative, and sort of wondering about it. One of our narratives when we think about existential risk is the notion of thresholds, boundaries, limits that if you pass, you go beyond that threshold, beyond that boundary, beyond that limit, then it's not quite the end of the world, but there's an implication that we've really ruined the planet once you go beyond those limits. I want to contrast that to an alternative approach, which would just be incremental degradation that gradually, at every step of the degradation, increases your risk. Those are two very different views. A threshold that once crossed, versus incremental degradation with every bit of degradation increasing your risk. What if there's uncertainty about where that threshold is? A really interesting paper came out 4 years ago by an economist at Columbia, Scott Barrett. I'm going to show you the result because I think it's useful for thinking about how our mind works when we try to think about this existential risk. So Scott Barrett looked at using a game with students in real cash. It was basically a game to simulate whether the students would give up cash to avoid crossing a threshold and avoid some bad impact. And there was uncertainty either in where that threshold was or the magnitude of the impact. The graph I'm going to show you is too complicated to explain, but I can do it by color. The basic idea is blue means the students played the game wisely environmentally and solved the crisis and cooperated. It's as though the whole world cooperated to reduce emissions. In fact, this game was constructed to simulate that issue. And the red means the students didn't. They just let the world go to hell, in this case, cross the threshold. If there's uncertainty in the threshold, you almost never get the cooperation. There's uncertainty in the impact that didn't matter. That's very, very interesting. So it's a very, very interesting way. Yesterday we talked a lot about how we speak about risk and so forth. Well, maybe this suggests, and I'll come back to this in a minute, that the way we talk about risk is degradation, and that every bit that we do puts us at greater risk, as opposed to there's some threshold that once crossed, we fall off the cliff. And if you think about it, some of us are gamblers. I'm a gambler. Those of us who are gamblers are going to gamble that the threshold's just a little bit further out there. And if you're uncertain, it's just too easy to allow yourself to do that. It would be interesting to explore this in more sophistication. Yesterday we heard a lot, and I think this is an important part of the narrative, and it even came up when you talked about children and grandchildren and what's going to happen, about the reinsurance time frame being 200 years. I don't think we've psychologically caught up with the fact that looking out there, there's some of you who are 20 years old, in your 20s. So if you're 20 today, you have a 1 in 2 chance of living to be 100. 80 years, 80 years. That distant horizon is not so distant. We haven't come to grips with the expanded lifespan and what that means for our time frame and thinking about environmental problems and risk. Just our culture and our civilization. Only 80 years ago, it was just 1 out of 10 lived beyond 65. Now it's 8 out of 10. So that's a rapid switch in our lifespan. And we still talk about distance in terms of next generation. Well, even if you're 40, you got a 1 or 2 chance of living to 95, that's, another 55 years. It's another 55 years. There's a lot of climate action that's going to happen in that you don't have to wait for your next generation. There's another interesting thing about risk and narratives. This is a study that was done and this more reflects, I think, sort of the Trump phenomena, the phenomena that, to what extent our own views about our own life shape our views about what's going on externally. And this is an experiment that was done that you asked individuals how their reactions, are all older individuals, you asked individuals how their reaction time had changed. And you found out that if their reaction time, if you asked them that first, and then asked them what they thought was going on with other drivers, they didn't see any change in driving on the motorways. But if you asked them what was happening on the motorways and did not ask them about the drivers, they thought things were getting much more dangerous out there. So they were sort of framing things in the context of what's happening to them. It's because of this that we've started at UCLA what we call Laboratory for Environmental Narratives. I think we have a real challenge in talking about all these extremely serious issues because we do not understand enough about how they resonate with the public or even with policymakers. And so instead of just talking about the end of the world, the true end of humanity, we might talk about post-apocalyptic civilization, but I think the really one that has the biggest effect is just increasingly dismal life. It's kind of, if you're a movie fan, Blade Runner. So just increasingly dismal life as we degrade the environment, we surpass its resource limits. The last point I want to make, and you'll learn this as a conservation biologist, but I think it applies to human existentialism, is so often when we look at risk as risk from nuclear war, risk from climate change, risk from overexploitation of resources, it's usually with species, it's not one thing, it's multiple things that get them. It's sort of the double whammy. If you look at the big environmental degradations that have huge impacts, this is the dust storm in the 1930s, where you could taste the dust in New York City. Massive migration to California. It was a combination of drought and bad agricultural practices. They were hit by two things. Same with the big dust storm over China, where the dust blew all the way to California. Again, it was a combination of drought, overgrazing, and overtilling the land. Not just one thing, two things. A lot of people are worried about buying up land, and big countries that are buying up land are South Korea, China, or Saudi Arabia, much of it being bought in Africa. We conservation biologists worry about it. The real problem with them buying land in Africa is it's not just the buying the land and the conversion, it's also that they're using water, and if you have a drought and they use a lot of water and they bought land, those three things are going to be extremely disruptive. It's not just one thing. Data shortcomings. And I think Tim is going to talk about this because he's found a way around this. But if you were to look at this number of species, here's the published estimates of the number of species. That's a log scale. They're all over the place. Talking about biodiversity at that scale, number of species on the planet, and expecting to pick up anything is possible. This is a real risk. Jeremy Grantham here in UK has drawn attention to phosphate. And it's a limiting resource. It's hugely, all plants need it. We've sped up the phosphorus cycle so much that the fertilizers run into the bottom of the oceans, and there's no way of recovering it. And so peak phosphate's a lot more scary than peak oil. Much more scary. I show the data there. Those are the plots. And then let's look at the uncertainty. These are the different literature estimates, published estimates, about how much longer we have on phosphate. These are the published estimates. So, from a theoretical point of view, we wish we had data like this, really fine-scale data, and you could see transitions in systems. And there's even been ecological experiments that have seen that data and collected that data for real lakes. This is an experiment in the Midwest whereby changing the lake by gradually adding fish and counting the prey, you could see before it happened, that's the middle portion here, before it shifted to a wholly different lake system, you could see this signal. We don't have much environmental data like that at the global scale. We have that type of biodiversity data. So I'll end with this. We have real material risk, and I've mentioned some. Phosphate, soils, water. You're going to hear about biodiversity. But degradation of phosphate, soils, and water, you can't find anything more tightly linked to just food and all of what that means. But we have conceptual shortcomings for how we deal with it. You know, we don't think about them very well because we don't think about enough about flexibility, evolutionary responses. We have what I think are ineffective narratives to motivate action. We have lousy data. You know, and Trump wants to get rid of the NASA satellites. And we think in silos. Risk analysis, risk of nuclear, risk of that, risk of famine, and so forth. Risk of war. And it's not silos from an environmental point of view. It's one thing on top of another. We know that from species. My last slide is ending up on reinforcing these. So 30 years ago, I was in a federal courthouse testifying about spotted owls, and we were certain it was logging. It was all logging. It turned out it wasn't just all logging. It was the barred owl, an invasive species that was moving from the East Coast. We were so, yesterday Claire talked about an open mind. We had such a closed mind that when we were testifying and we heard the data about the barred owl, we thought it was just a logging company ruse. And they were just lying to us. It turned out it was real. And so it's really hurting us. But now there's a bounty on barred owls. So it's a combination. It's not just a loss of habitat, it's the species moving in. We wanted there to be experiments, and the federal government tried to set up different logging experiments. They could never get the industry to do it. They wanted to understand, to this day, they understood the need for logging experiments and different ways of managing the land to save that species. Never succeeded in getting experiments done. In salmon, it was all about the narrative and the symbolism was getting rid of dams. When we did the math, it was published, we found out if you got rid of dams, there's enough data to say it wouldn't have saved the salmon. Wouldn't have done any good. You get rid of the dams, could have done good things for other things about the system, but there's no way it would have saved the salmon. It was hatcheries. Hatcheries and hatchery fish were reducing the diversity, reducing the ability of the species to respond, and even though we had spent $250 million on science in a 10-year period, not on management, $250 million on science, it was misled by the symbolic and sort of closed-minded focus on dams. It wasn't just dams. Probably the greatest threat to salmon in the Pacific Northwest is hatchery fish. And I think I'll leave it there. Thank you.
Suggesting earlier, we will have questions for about 5 to 10 minutes and then move to the next lecture.
Hi, thanks. It was a very interesting talk. I wonder about the extent to which biodiversity loss could be thought to be like an existential risk to humans. So if you look at species extinction in the past, they tend to be kind of not very globally dispersed and very kind of localized and subject to sort of natural stresses, whereas humans are globally dispersed, very numerous and capable of a sort of rational response to problems. So that might be a reason to think that these kind of environmental systemic threats it's going to be hard to kill us off in that way.
So we're going to hear, a whole talk about biodiversity as an existential threat. I'll just give you sort of my view on it. I think about it as biodiversity as an insurance. It's a biological insurance. And it's that insurance and it provides redundancy. It's you know, you lose one species, you got something else to fix nitrogen and so forth. So I think of if we lost redundancy in our biological systems, certainly biodiversity loss could be an existential threat.
One tool in conservation biology that I've been interested in is minimum viable populations. I started looking around the literature to try to see, had somebody calculated minimum viable population for humans, and I couldn't find it. So in the end, I rolled my own code and realized, oh, this is pretty tricky. So I'm curious both about what you would recommend for actually trying to simulate the minimum viable population for humans, and also whether you would think that actually works, because obviously, especially if you try to set up, let's say, a refuge after a disaster, you can tilt the balance in interesting ways. You can actually set up weird gender ratios, etc. But could it be that there are other tools in conservation biology we in the existential risk community should actually learn and pick up and see if we can apply to human systems?
That's a really interesting question. It draws me back about 20 years of my career. But when you do minimum valuable population size, inevitably what drives it is variability. And as you increase variability, you need more and more of a minimum population size. Our population is not that variable. If you were to do it, though, you might do variability in things like food supply, or sort of ultimate drivers of what does our well-being, where we might be able to have a little bit better data. The other thing population biologists do is they look at threats. They do a threat analysis, and they ask. You know, you get a long list of threats, and you say, how might this cause extinction, and try to estimate the probability of it. I think that approach would be extremely useful for the human situation. Oliver.
Zabta Shinwari, Pakistan Academy of Sciences. Excellent talk. Just an observation, one of your slides, you said extinct species versus human, either domesticated or hybrid species, the number game. But for one point of view, I think both are going other way around. If you extinct, there is an ecosystem, you disturb not only one species, but the whole ecosystem around that species, micro and macro. And if you introduce something, either domesticate, otherwise, or recreate the extinct species, that has negative impact again. So shall I take your slide as a positive that we do something good, or both are in fact contradicting each other?
So there's no question that non-native species, introducing a species, can have negative effects. I think it's a mistake to assume that they do. And I think it's closing options to, I would use the parrot example in Los Angeles. You could, in Los Angeles, decide it's a non-native bird, let's exterminate it. Or you could say, embrace it, and as a result of that, that bird might persist on the planet, reducing the sort of existential risk of losing some redundancy, because if you don't embrace it in Los Angeles and Mexico, you lose it. So I think I do not think that non-native species or introduced species are inevitably a bad thing.
It may become invasive when they are saying, can we take the next question? Who else? You have it.
Matthew Bone, University of East Anglia. So thank you very much, Peter. It's a really interesting talk, and you're spot on with relation to droughts and water stresses. So we're actually also seeing these effects now. We've seen them in Syria back in 2008, where we had a 3-year-long period of drought, which you look at the situation now, contributing factor. Again, looking at this holistic system, as you were saying, it's not just one effect. So I was quite surprised actually by your phosphorus graph. Certainly from the 1950s, yeah, you see this big peak, and you're starting to comment saying that we're going to run out of phosphorus, which will affect our nutrients for agriculture. So could you tell me a bit more about that, please?
So that's not my idea. Jeremy Grantham's written about that as sort of one of the key economic risk and trends that he pays attention to. And if you look at the literature, the issue with phosphorus is that once it runs into the ocean, it's lost to us. It's not like nitrogen. We have nitrogen-fixing organisms. If we run out of it, we don't have a substitute. It all comes down to estimating how many stores there are, how much storage we have of phosphorus. There's 4 countries now that are the major stores: Morocco, US, China, and Russia. And the variation, I showed a graph of the variation and how many years we have left, has to do with variation, not in the estimate of the rate at which we use it, because that's pretty solid, variation in our estimation of the storage.
I think there was a paper way back in the late 50s, early 60s by Alvin Weinberg and a co-author, and they went through the periodic table and looked at the expected life of the amount, the stocks of the elements, and phosphorus was the limiting one.
Yeah.
And it's okay, we'll take 2 more questions.
Guano is gone as well, all the islands.
Right.
You have a question.
Yeah, Peter, I thought it was wonderful way that you drew out the tension between a view of
nature as fragile and static and a view of life as adaptive and having lots of capacity. And I thought it was fascinating to bring out the example of Gough Island. But of course, there are 2 sides to the story in Gough Island, because the mice have been a huge adaptive success. The albatrosses, really not so much. I mean, they've spent 100 years not working out that being eaten by mice is a bad thing. So how do you distinguish the bits of nature you want to take your positive adaptive message from, and the bits of nature that are really saying, hey, if you mess with us, we all die?
I don't think we were all going to die for that man-eating mouse, even though Hollywood might. The albatross. No, I do think you're spot on with it. I mean, that's why I had some sort of, you know, when you're a biologist, one of the reasons you love diversity, even though we all talk about its usefulness to humans' well-being, is just we think it's cool. We think that what nature has invented is cool. And I was really drawing out that mouse because as a biologist, that's just amazing to me. As somebody who worries about biodiversity and sort of long-term view, your point is exactly right. Its remarkable success is putting at risk albatrosses and not just petrels and the other birds on the island. Yeah.
We'll take 2 more questions.
So this sort of follows up on the last question. When we're talking about existential risk, there's sometimes we mean something like the risk is on our species, but often, and I think more interestingly, we mean on certain types of ways of life and certain types of cultures which we think are important. And it strikes me that there's a way of making your degradation point stronger by expanding the way you're talking about conservation biology. Because it strikes me that conservation biology, at least often, is not about owls. It's not about pointing at a species and going, I want to save that species. We want to save particular types of ecosystems. I say this also agreeing with the, man, it's really cool when they do these surprising things, by the way. I agree with that. So it strikes me that pointing out that what we're interested in is protecting certain types of systems, certain types of often quite small-scale ecosystems that we think are important for whatever reason, right? That tracks the idea of existential risk in terms of certain types of civilizations or cultures or something like that. And I think when you're thinking in that kind of idea, the idea of degradation looks significantly more problematic, right? Because it's precisely that which is disappearing. It's the things that we think make human life valuable or something like that. So perhaps if you expanded the way you were talking about conservation biology as being about the protection of ecosystems or particular places, as opposed to owls and fish, that might make the degradation point stronger.
I couldn't agree more. That's why when I showed the 4 movies and sort of the Blade Runner scene, to me, that is what is the most likely form of sort of existential risk, and it's also the most discouraging and motivating form.
I'm Ray Taylor. I'm a communication teacher and trainer, and I work with David Denkenberger on catastrophic risk. And I'm asking this question assuming that at UCLA, one of your focuses is communicating environmental messages in a way that actually works rather than gets people depressed and hopeless. Is that?
So that's why we formed this laboratory for environmental narratives. It's with the film industry, art, music, all that. Yes.
Fantastic. Okay, because I was hoping you could say a bit more about that and what you're finding works. And I wanted to kick you off by saying that I've done quite a lot of work using nonviolent communication on this. And what people really seem to like having is something they can do. Something that will actually make a real. That's why people are so desperately looking for you know, and the NGOs as well want something they can ask people to do to get them involved, and as far as public messages go. And then I've got two prejudices which you might be able to destroy about ecological footprinting and offsetting, which to me seem disastrous ways of communicating anything. But maybe you know better.
We can keep that. Sure. That gives you more time to think about it.
Thank you very much. That was great.